In the modern laboratory, scientists spend their days studying the complex interactions between chemicals, microbes, and human cells. They understand, perhaps better than anyone, that what we call food in the fast food industry is often a sophisticated feat of chemical engineering designed to bypass our natural biological defenses. While the average consumer sees a convenient meal, a scientist sees a collection of metabolic disruptors, immortal fats, and neurostimulants. To those who understand the molecular reality of these ingredients, certain menu items aren't just unhealthy, they are biologically unrecognizable. Quick favor before we move on. If you appreciate this content, consider giving this video a like and subscribing to the channel. Believe it or not, more than 92% of viewers haven't subscribed yet. It's free and only takes a second, but it means the world to us. So did you subscribe already? Great. Thank you so much for your support. Now back to the video. 1. The non-dairy whipped topping. Why number 1? It is a chemically stabilized emulsion of hydrogenated palm kernel oil and high-fructose corn syrup that defies natural decay. If you look at the whipped cream sitting atop a fast food frappe or sundae, you'll notice it stays stiff and peaked even in sweltering heat. A scientist knows this is because it contains almost no dairy. Instead, it is a slurry of hydrogenated oils, emulsifiers like polysorbate 60, and thickeners like xanthan gum. The primary concern here is the molecular structure of these fake fats. They are engineered to be indestructible on a shelf, which means they are equally difficult for your cellular machinery to break down. These synthetic lipids can integrate into your cell membranes, affecting fluidity and signaling. To a scientist, eating this isn't a treat. It's like ingesting a tasty, pressurized form of industrial lubricant. 2. The pre-grilled chicken breast. Why number 2? The grill marks are often chemically applied, and the meat is injected with phosphates to hold weight and moisture. That perfectly charred, juicy chicken breast in your salad or sandwich is rarely what it seems. In a factory setting, liquid smoke and caramel color are used to paint on the appearance of fire grilling. More concerning to a scientist is the use of sodium phosphates. These chemicals are used as plumping agents to ensure the chicken stays moist after being frozen, thawed, and reheated. High levels of dietary phosphates are linked to accelerated aging, kidney stress, and vascular calcification. A scientist understands that while the chicken looks like a lean protein choice, it is actually a delivery vehicle for mineral-disrupting additives that mess with your body's calcium balance. 3. The infinite fountain soda. Why number 3? Beyond the sugar, the caramel color 4, and the phosphoric acid act as a dual threat to metabolic and bone health. To a chemist, a fountain soda is a highly acidic solution of high-fructose corn syrup, HFCS, and phosphoric acid. The phosphoric acid is what gives soda its bite, but it also leaches calcium from your bones to neutralize the acidity in your bloodstream. Then there is the caramel color 4. Produced by reacting sugars with ammonia and sulfites, this process creates a byproduct called 4-MEI. In laboratory settings, 4-MEI is a known carcinogen. When you combine the massive insulin spike from the HFCS with the bone-leaching acid and the chemical coloring, the value-size soda becomes a metabolic storm that no scientist would willingly invite into their system. 4. The pressed chicken nugget. Why number 4? These are meat hybrids containing TBHQ and dimethylpolysiloxane, chemicals also found in cosmetics and silly putty. A chicken nugget is a triumph of meat glue, transglutaminase, technology. It is a slurry of connective tissue, fat, and pink slime that is reshaped into a familiar form. To prevent the frying oil from foaming in the vat, many chains add dimethylpolysiloxane, a silicone-based anti-foaming agent. While the FDA deems it safe in small amounts, a scientist looks at the cumulative effect. They also worry about TBHQ, tertiary butyl hydroquin, a preservative used to keep the processed fats from going rancid. In high doses, TBHQ has been linked to DNA damage and precancerous cellular changes in lab animals. A scientist sees a nugget not as chicken, but as a synthetic polymer of animal byproducts and industrial stabilizers. 5. The butter-flavored movie theater popcorn. Why number 5? The butter is typically a soy oil-based yellow dye containing diacetyl, a chemical linked to popcorn lung and neurological decline. The butter pumped onto fast food popcorn is a chemical illusion. Its primary flavoring agent was traditionally diacetyl. While most chains have moved away from it due to its link to respiratory disease and factory workers, the natural replacements are often structurally similar shadow chemicals. A scientist understands the aromatic volatiles involved here. These chemicals are designed to be volatile, so they hit your olfactory sensors instantly. But these same compounds can cross the blood-brain barrier. Studies have suggested that certain butter-flavoring compounds can increase the clumping of beta-amyloid proteins in the brain, a hallmark of Alzheimer's. To a scientist, that smell isn't appetizing. It's a warning of neurochemical interference. 6. The American processed cheese slice. Why number 6? Legally, it's not cheese, but a pasteurized prepared cheese product held together by emulsifying salts. If you leave a slice of fast food cheese on a counter, it won't mold or melt. It will simply sweat and eventually turn into a plastic-like disc. This is because it is a slurry of milk proteins, vegetable oils, and sodium citrate or sodium aluminum phosphate. These emulsifying salts allow the cheese to melt perfectly without breaking into oil and solids. However, the aluminum used in these salts is a neurotoxin that accumulates in the body over time. A scientist understands that the perfect melt of a cheeseburger comes at the cost of consuming industrial minerals that have no business being in a biological system. The bottom line: a scientist's refusal to eat these items isn't based on a desire to be skinny. It's based on an understanding of chemical bioaccumulation. We are the only species on Earth that consumes edible food-like substances created in laboratories. When you strip away the branding and the salt, you are left with a collection of industrial byproducts that prioritize shelf life and mouthfeel over the basic requirements of human life. This rejection stems from a deep respect for the metabolic pathways that evolved over millions of years to recognize whole molecules, not synthetic isolates. To an expert, these convenience items are biological glitches, foreign compounds that accumulate in our tissues and disrupt the delicate signaling of our hormones. We are trading our long-term cellular health for a momentary hit of engineered dopamine. The molecular reality. The human body is an incredibly resilient machine, but it is not designed to process immortal lipids or synthetic anti-foaming agents. Every time we consume these lab-engineered items, we are asking our liver and kidneys to solve a chemical puzzle they weren't evolved to handle. True health isn't just about counting calories. It's about respecting the molecular integrity of the fuel we put in our engines.